All right, increasing and decreasing intervals. Okay, so real quick, we just want to look at what's increasing and decreasing. So, right, we could see this is increasing, and then it decreases, increases, decreases, right? So when the slope is when the slope of a function is positive, the function is increasing, right? Pretty obvious. Right, the slope is changing, right, if we did a tangent line, but we can still tell it's going up. And then when the slope is negative, the function is decreasing. So if we look at our critical points, we have one right here, one right here, and one right here. Right, so this is when, if you remember, this is when the derivative is 0 or the derivative does not exist. Right, so right here it's 0. Because the slope is 0, and then right here it's a cusp, so it does not exist. So when you have these critical points, you want to make a chart. So we have these 3 critical points, right, at 3, 5, and 6. So we're going to put 3, 5, and 6. And then on either side, we're just going to have a range. So we have negative infinity to 3, 3 to 5, or an interval, right? 5 to 6, and then 6 to infinity. So we're taking our entire graph and we're breaking it down into these sections. So now we just need the sign of f prime of x. So remember, when we have our critical points, we know that it's either 0 or does not exist. So at 3 it's 0, at 5 it's 0, and at 6 it does not exist. Right, this is our derivative. Okay, so we're looking at the sign of f prime of x, but remember, this is saying like the sign of the slope, right? Of tangent line. Right? So if we're looking at the sign of this section, so we're going from negative infinity to 3, what is the sign of this section? Is it positive or negative? Nice, positive. What about this section from 3 to 5? Nice. 5 to 6? And 6 to infinity. Very nice. Okay. So remember, we just need the sign, we don't need the value. Okay, so let's look at an example problem. Find the intervals on which the function f of x equals negative x squared minus 4x minus 1 is increasing and decreasing, and justify your answers. So here it sort of breaks down the steps. So first we got to find the critical points. So remember, when we're finding the critical points, we need our derivative. We need our derivative to be 0 or our derivative to not exist. So we're going to start with our derivative. F prime of x equals what? Nice, negative 2x minus 4. And there's no value where this does not exist, so we're going to set it equal to 0. And, okay, so when we're solving for 0, move over the 4. Negative 2x equals 4, divide by negative 2. X equals negative 2. Right, so this is our critical point. I'm going to make it red because we've been using red for critical points. Okay, next step. In between the x values, the derivative must be positive or negative. So we're going to use a chart to help keep track of the information. Write the critical points of the derivative first. So we only have one critical point, so we just need to plop that in. I'm going to make it red. We know that it was 0. Because we solved it for 0. And then this interval is going to be negative 2 to infinity, and then the interval in front of it is going to be negative infinity to negative 2. Okay, so right here we're going to get positive, and you could do it by a few ways. You could just plug in a number. You could pick like negative 3. And we're going to look at this original equation right here. So we have negative 2x minus 4. That's our f prime of x. And let's plug in like negative 3. So negative 2 times negative 3 minus 4. We get 6 minus 4 equals 2. That's a positive number. And then if we do negative 2 to infinity, since 0 is in this band, it's easier to use 0. Negative 2x minus 4, so we get negative 2 times 0 minus 4. 0 minus 4 is negative 4, so this is a negative. So you can do a few things. You can pick a specific point in the interval like we did. So let's do like 1, pick specific point. Or 2, you can sort of like just guesstimate using like a big number. Like use a guess or like a round. Right? So if I'm thinking of negative infinity is like a super huge negative number. So if I have negative 2 times a negative huge number minus 4, this is going to be a positive number, but it's going to be really big. And then minus 4, that's still going to be positive. So you should know that huge positive minus 4 is still positive. And then for here, we have negative 2 to infinity. So if I plug in infinity, right, I can do negative 2 to infinity minus 4. That's negative. A negative number times infinity is going to be really negative, and then even more negative. So this is going to be negative. So this is like something that some people don't grasp that well. Sometimes the plugging in is more concrete, but it's quicker if you can use like a guesstimate. So you want to like, remember, you're not trying to find the actual value, you just want to know if it's positive or negative. So sometimes it's helpful to just think in like more abstract terms, but if you don't like that, then just pick a specific value. Nice. Yeah, okay, so let's look at the graph, right? This is the original graph. This is f of x in blue, and this is f prime of x in red. So you can do it with graphing, but you want to be able to do it without graphing. So that's why calculus is important, right? So we know that it's increasing from negative infinity to 2, and it's decreasing. But if we look at the graph of the derivative right next to it, we can see, right, it's positive until it stops increasing, and then it becomes negative. So these are how the graphs intersect. It can get a little tricky, but essentially you should know if derivative is positive, it's increasing. If derivative is negative, it's decreasing. And obviously in the future you're going to get graphs that are more complicated than this, but that is the basis of it. So just to recap, first we found the critical point, then we made this chart, and we figured out if it was positive or negative using the derivative. Okay, now we have our script, right? So this is like what a professor or the AP, people, graders would want to see. This is just showing me that you can explain with your words what is happening with the math. So answered statements with justification. So you can say f of x is increasing on negative infinity to negative 2 because the derivative of f of x is greater than 0, or is positive, right? So the original equation is increasing because the derivative is positive. And then similarly, f of x is decreasing on, and then you have to give the specific interval, negative 2 to infinity, because f prime of x is less than 0. So I'm saying OG equation is increasing because derivative is positive. OG is decreasing because derivative is negative. So there's going to be a lot of confusion when you're doing these problems between remembering, am I in the original equation or am I in the derivative? And that will just take a lot of practice. All right, next side. Okay, why don't you try this one on your own? Remember, our steps are critical points, using the derivative, making the chart, and finding the sign, and then your answer statements. So I'm going to pause the video. Okay, so we want to take the derivative of f prime of x, so that's going to give us 3 times 1/3 is just 1, so we get x squared minus 2x minus 15. If we want to factor this, we can do x minus 5, x plus 3, because we set it equal to 0. So we have two different versions of our derivative. We have it in standard form and we have it in factored form. Here in factored form, you can clearly see that x equals 5 and x equals -3. So those are our two critical points, which I will put in red. So you have -3, 5, and we have 0, and now we have our ranges. So -3 to 5, 5 to infinity, -infinity to -3. Okay, so there's a few ways to do this. You can check using the standard form or the factored form. So let's start with the one where the 0 is, because that's always easier. So for this one, I'm going to plug in 0, and I'm going to plug it into the standard form because it's really easy to see, right? F prime of 0 equals -15. So I know that this right here is going to be a negative sign. Okay, so then next I'm going to look at, I'm going to do the infinities and then I'll do an actual value. So I'm going to do the infinity with the factored form. So if I have infinity minus 5 times infinity plus 3, infinity minus 5 is still going to be a positive number. So essentially I have positive times positive equals positive. So I know that this one's positive. Okay, let me label the work so you guys can follow it if you look back. And then here I'm going to plug in negative infinity. So negative infinity minus 5 times negative infinity plus 3. So this is still negative, and this is going to be negative, and negative times negative is positive. So this is positive. Right, so sometimes you can just think to your head, like, is it going to be a negative times a negative times a positive, instead of actually calculating it out. But if you wanted to, you could plug in a value. So let's do 6, right? So if I have 6 minus 5 times 6 plus 3, I have 1 times 9, which is 9, which is positive. And then alternatively over here, I could have plugged in like -4. Let's plug it into the standard form just to show that it works. So -4 squared minus 2 times -4 minus 15. So that's 16 plus 8 minus 15. I don't even need to know what it is because I know that it's positive. But this is what I'm looking for. I'm looking for positive, negative, positive. So however you want to figure it out, we just need to know. So now we need our answer statements with justification. So we have f of x is increasing on the intervals negative infinity to -3 and 5 to infinity, because f prime of x, our derivative, is greater than 0. It's positive. You could write it's positive, but you want to be able to like read this and understand, right? This isn't in English per se, it's in math, but you should know that this means is positive. And then our other statement is f of x is decreasing on -3 to 5 because f prime of x is less than 0. So while you're finishing that, I'm going to put these graphs in the calculator. And you can always do this to sort of conceptualize what you're doing. But it's not necessary to graph. The whole point of calculus is to be able to find out this information without a graph. X squared minus 2x minus 15. Okay, let's see if I need to change it. Okay, yeah, let me zoom out. Alright, so my original graph is a nice parabola. We have 3 crosses. And then if you look here, my derivative is now not a straight line, right? So my derivative is positive in this section right here and this section right here. And that's where the graph is increasing. And then my derivative is negative right here. And that's where the graph is decreasing. So like I said, it can get a little trippy when you're looking at both of the graphs next to each other. But you should be able to look at a graph too and sort of understand what's happening, right? This original equation, increasing, decreasing, increasing, right? Increasing, decreasing, increasing. Okay, just to clarify, right? When we're trying to find these, we're going to plug in a random number into the derivative. So I don't want to see you plugging in 6 into the original equation. You need to plug in 6 into the derivative that you found in the first step. Okay. Few more problems and then we are done. Okay, so this is a graph of f prime of x. So you need to be very careful because this is already the derivative. Okay, so this is already telling us if it's increasing or decreasing. So determine the intervals where f is increasing and decreasing based on the graph of f prime. So if this was a graph of just f of x, then we'd be like decreasing, increasing, decreasing. But this is the derivative, this is the derivative graph. So increasing is going to be where it's positive. So it's this chunk. And then decreasing is where it's negative. Right? So it's increasing from negative infinity to negative 3 and 1 to 3 because f prime of x is positive, right? And then similarly, it's decreasing from negative 3 to 1 and 3 to infinity because f prime of x is less than 0, is negative. Right? So this is a trick question. The graph is already showing f prime of x. This answer would be completely different if this said f of x, but since it says f prime of x, we're not looking at if it's decreasing, we're looking at if it's positive or negative. One last problem, application of rate of change. If you want to know if something is increasing or decreasing, you look at the sign of its rate of change. So essentially, this is just saying what we already know. If you want to know if the original is increasing or decreasing, we look at the sign of its rate of change. And rate of change is the same thing as derivative or slope of original graph of f of x, not of f prime of x. Okay, so derivative, rate of change, slope, it should all be the same thing, right? It's change in y over change in x. So the sign of a rate of change can tell you if the dependent, let me write this in a different color, dependent variable is increasing or decreasing. So you want to be able to differentiate between f of x and f prime of x. So the rate of change is f prime of x. The dependent variable is like f of x. So this is f prime of x. This is f of x. Okay, so this can be confusing, but hopefully with a few examples it makes sense. So it says students per year is increasing. So this is the derivative. This is f prime of x. So if we're trying to know about the original thing, we can say number of students is increasing. Right? If students per year is positive, if we're getting more students every year, then our number of students is increasing. This seems sort of redundant, but you want to be able to differentiate. Right? So now we're in the dependent variable. We're not saying students per year, we're back to students. Right? So if students per year is +1, that means every single year Hancock is getting one more student, which means our number of students is increasing. Right? Miles per hour is less than 0. So this is our derivative. So we want to go back to f of x, right? This is f prime of x, miles per hour. So if I'm going to f of x, which is just miles, I could say number of miles is decreasing. Okay, let's look at mastery checks per week is increasing. Right, mastery checks per week is increasing. Number of mastery checks is increasing. Right? If the rate is positive, then the dependent variable is increasing. This one's a little tricky. So we have virus cases per month squared. So this is f prime of x. And f of x, the units, is not virus cases, but it's virus cases per month. So instead of month squared, it's month. So this, you can almost think of this as the second derivative, and I'm going back to the first derivative. So I can say number of virus cases per month is decreasing. So this is a little trickier, but remember, we're just going one level down. Right, so this one we took away a year, this one we took away an hour, this one we took away a week, this one we took away 1 out of the 2 months. And we have our new unit. Okay, last thing. The rate of change of fruit flies in Mr. Kelly's kitchen at time t days is modeled by R of t equals 2t cosine t squared flies per day. Show that the number of flies is decreasing at time t equals 3. So this one's actually tricky because it looks like I need to take the derivative of R of t, but it already is an equation of rate of change. So this is already a rate of change function. So instead of taking the derivative and then plugging in t, we just need to plug in t, and then we should be able to tell if it's increasing or decreasing. So if I do 2 times 3 cosine 9, and I'm pretty sure I need to be in radians, 6 times cosine 9, I get negative 5.4. Okay, so I can say number of flies is decreasing at time t equals 3 because R of 3 is less than 0. Right, so this is flies per day, and I wanted to know about flies. So this is the derivative. I needed to see if it's positive or negative, and then it told me that flies was increasing or decreasing. So this is the tricky part of this lesson, is knowing where you are. Am I in the derivative or am I in the original equation? Or am I in the second derivative or am I in the first derivative, right? Like this was a second derivative to first derivative. So as you go through the practice, make sure you're checking your answers, and hopefully you can start getting quick with your positives and negatives.